Class. Today's the first proper lesson that we're going to go through. I just want to start by giving you a second to open up the notes that I posted along with the video on Google Classroom. I highly recommend having the notes in front of you as you listen to this. So if you want to pause the video now and pull your notes, that would be great. All right. I also posted along with the notes a sheet on steps for solving conversion questions. This will be very helpful just to reference when we get into some more conversions. For today, we don't need it, but I just put out there as a reference and I'll refer back to it in future videos. So let's start by going over perimeter and area review problems today, or review. So I just want to kind of get you started, nothing new, just what we've gone over before, just so we can kind of get everybody on the same page. So let's start with perimeter. So I start by defining perimeter as the total length of the outside of a shape, and that it's one-dimensional. So the total length of outside the shape, that's just if you run your finger around the edge of the shape, it's the distance your finger travels. And one dimensions means it's like a line. It doesn't have a side, area to it yet. It's just like a line, which is going to be just like the outside of the shape. So just that thin line on the outside of the shape. I wanted to start by looking at the perimeter of a circle. So a perimeter circle, we call it a circumference. So we changed the name a little bit, but it's the same idea. It's just the distance you go around the outside of a circle. Circles are a special shape, so we call it circumference. So the perimeter is going to equal C, and that is going to be pi times diameter. So pi is a constant that we refer to, and it refers to the number 3.14. So pi is in your calculator. You can also just use the number 3.14 for pi. The diameter of a circle is the distance from one edge to the other edge when you go through the center. So if you look at the circle that I kind of drew over the equation by accident, we go through the center point, and it's from one edge to the other edge of that circle. That's going to be your diameter. So again, the perimeter is, or the circumference, is pi times that diameter. Right. So feel free to pause the video if I'm going too fast and just get your bearings. You can go over it again and again as well if you'd like. Okay, so on the circle I've drawn here, I have the diameter, but I also have the radius. So the radius is from the center out to any point in the circle. It's going to be the same value from the center to any edge, as long as it's a straight line. So I say here the diameter is D, and that it's 2 times the radius. So it's twice the size of the radius. You can see that by the diameter being from one end to the other, the radius is going to be half that from the center to one end. So on the circle I've given you, there's an example question where I'm going to say the radius is 5 centimeters, and I want you to find C. So to do that, some of you will have the circumference equation using radius, but just so everybody's on the same page and for simplicity, we're just going to look at the one where we have diameter. So circumference is pi times diameter. So to find the circumference, we want to find the diameter first. So the diameter is going to be twice the radius, so we've got 2 multiplied by 5 centimeters. This is going to give us a total of 10 centimeters for a diameter. So now our circumference is going to be pi times that diameter, so pi times 10 centimeters. And that is going to give us our 31.4 centimeters. Okay, so moving on to our other shapes. For any other shape you're going to see, in my class anyways, what you want to do is just add up the sides. So there might be some trickier shapes where this won't work, but we'll get into that if we get there. So for adding up the sides, we're just taking each side length and we're going to add it together. So this works for triangles, squares, hexagons, pentagons, mostly pretty much every shape that you're going to see, unless it has some sort of a circle in it. So some shapes might have a half circle, or a full circle in it where we need to find the circumference of that part of a circle or full circle. But for now, we're just trying to add the shapes up. So let's look at example 1 here. We have a triangle. I labeled one side as being 3 centimeters long. And I put a dash in all 3 sides. This dash is referring to each side being the same length. So we know that each side is 3 centimeters long. So when we find our perimeter, we want to add up each side. We have 3 of them as it's a triangle. So we have 3 centimeters plus 3 centimeters plus 3 centimeters. So now that's going to give us 9 centimeters as a total perimeter. We can also look at this question a little bit different. Because we have 3 sides the same, we can just refer to perimeter as being 3 multiplied by 3 centimeters. Because we have 3 sides, we're just multiplying the side length by the number of sides we have, 3. And that is also going to give us 9 centimeters. You don't have to do it that way. That's just a separate way of looking at the problem. Okay, moving on to question 2. I've given you a bit more of a complex shape. So it's a square or a rectangle with a side cut out of it. Now, I have not given you the side lengths, x and y. We're going to go through finding those lengths, and then we're going to solve for the whole perimeter. So first, finding x, we can look at the shape. The bottom of the shape is 7 centimeters, and we know the top is 4 centimeters plus this x bit. So if we don't worry about the side length, just the top and the bottom, we get the bottom is 7 centimeters, and the top is going to be 4 centimeters plus that x value. So we're looking at just side or lengths that are going across the page. So we know that the shape is the top and the bottom together are the same size. So that means that 7 centimeters is going to equal 4 centimeters plus x. So we can rearrange this a little bit, and we can see that our side length x is going to be the difference between 7 centimeters and 4 centimeters. So if you just remove that 4 centimeters from the 7 centimeters, you'd be left with the length of x. Now you can do this if you want with a ruler. If you take your ruler and block off 4 centimeters on that bottom side, the 7 centimeter long bottom edge, and you cover that the whole shape of your hand, you can see that what's left is the x value, and it's going to be the x side, and it's going to be the same as whatever amount you have left on the bottom side. So we're left with x being 3 centimeters. So x is 7 centimeters minus 4 centimeters, giving us 3 centimeters. So we can do the same idea with our y side, and we can just worry about the vertical lines this time. So we see that on the right side, we have 3 centimeters. On the left side, we have 2 centimeters and y. So again, we'll have 3 centimeters is equal to 2 centimeters plus our y value. So our y value is going to be our difference between 3 centimeters and 2 centimeters. So that gives us y equals 3 centimeters minus 2 centimeters, giving us 1 centimeter as our side lengths. All right. Now, if we flip over the page, I ran out of space, so on the back of the page, we continue on this problem, and we're going to add up all the side lengths to find our perimeter. So we add them all up, and we fill in our values for x and y. So that first line, p equals, and all those values, those are just all my sides. On the second line, I'm going to add the values we found in for x and y, and then I add them up, and we get 20 centimeters. And I just want to clarify that this is still in 1 dimension. We're not multiplying any values together. We're purely adding values. So our unit doesn't change. Our unit stays as a centimeter in 1 dimension.